The first part of the zinc plating process is to make sure that we can conduct an electrical current through all of the parts we want to be plated when we put it into the electrolyte. So in the case of home plating and the kits that you can buy, you need some kind of metal conductive rod. In this case, this is just an extension for a socket set, an old socket set, and these are copper wires. The reason they look silver rather than copper is just because they've been through the plating process before, so these have ended up being zinc plated. But basically what we're going to do is we're going to attach all of our parts that we want to plate onto these wires, and I try and if I can do a batch at a time, just because obviously it makes the process quicker, although there are limits on the amount you can do at one time depending on the amount of current that you're able to pass through the electrolyte, but we'll come on to that when we do that shortly. So the first thing I'm going to do is put all these onto this wire, and then we'll come back when I've done that. Right, so all of the parts that we want to plate are now connected up to the metal bar, and the pegs are there just to make sure we've got decent conductivity. And the next stage is to go over to the tanks, and we'll go through those. Just before we get underway with the process itself, I'm just going to run through the setup I've got going on here. You do need a reasonable amount of space for this. I mean, this is all just balancing on the top of an old chest of drawers. So let's start at, well, the first tank where all the parts go. I've labelled these up just because so I can keep my eye on which one's which, but this is our cleaner and degreaser. The parts, when they're plated, have to be as absolutely clean as possible. And you'll also notice that on the side of these we've got, or on some of these, there are little thermometers. Each of the tanks has a small, well, these are actually fish tank heaters, 50-watt fish tank heaters. And you do need to warm up all these solutions before you use them. So we've got the degreaser to start with. Then we have an acid pickle. So our acid pickle is basically, once we've cleaned everything up, that really gets rid of absolutely everything else that might be contaminating the surface of our parts, and also provides it with a key for the electrolyte to do its job, and the zinc to adhere to the surface of our parts. This tank, our third tank, is the electrolyte, and this tank's slightly different in that we've still got our heater in there, but we also have 4 zinc plates, and each zinc plate is connected to its own piece of wire, and in turn each of those pieces of wire are connected to a piece of wire that runs around the whole tank. So each of those electrodes are connected to this wire here, and that wire is then in turn connected into our power supply. Now, this power supply I bought off Amazon. It wasn't part of the kit. The kit did come with its own power supply, but there was no way of regulating the current, and that's an important step and a point which we'll cover shortly. Once our parts have been through the electrolyte, which is the longest part of the process, we then have something called a green surfactant, and chemically, I'll be honest, I don't entirely know what that does. I think what it does is once the plating process has been completed, the surfactant is, I tell you, it smells and feels like a strong solution of fairy liquid, if I'm honest. I think it is just some kind of cleaner and possibly a way of making the surface to be able to get the surface ready to be able to accept whatever passivate we're going to put on. So normally, once you've done the zinc process, you then dip into the green surfactant, and then you go into the passivate of your choice. In this case, the one we're using is a clear/blue passivate, which whenever you see fixings on Japanese motorbikes, some of them actually look chrome, but they're not always chrome. Quite often they have been zinc plated and then have been put through a clear passivate, which is there to protect the surface and protect the zinc coating. You can get other passivates as well. In fact, if we come over here, I also have a black passivate, a yellow one or yellow gold one, and the one at the bottom, which you can't quite see, is actually olive drab. So olive drab, imagine sort of army green, if you like, or military green, or in actual fact, if you go and look at a Yamaha RD 350LC or 250LC that's had, look at the kickstart, that is olive drab. And I think there's a couple of other parts on that bike that's are meant to be olive drab as well. A lot of them aren't these days because when they've been restored, they've been done with something else. But it's not used very often on bikes, to my knowledge. Each of these passivates provide a different level of protection. My understanding from what I've read is that the clear passivate provides the least protection. The gold, yellow one and the black are pretty similar, but they provide more protection than the clear one. And then the olive drab one provides the most protection. When I say protection, what I mean is longevity. That's how the olive drab one will last longer than any of the others, which I guess is why it's used in the military so often. So let's talk about current settings. So this is just a standard variable power supply, which you can buy from Amazon. And if we switch that on, let it go through its setup. So I've replicated here charging or using a battery basically. So we're set at 12.5 volts and 2.5 amps at the moment. Now, this is the important thing because we need the amps, the amount of current which is going through the parts is the most important thing. The voltage is irrelevant. The important thing is how quickly the current is flowing between our zinc plates, and therefore the zinc coming off the plates and coating onto our parts. If it's too rapid, then you end up with parts that look rough and are dull. And if the current is too low, you end up just taking an awful long time to get the parts zinc plated, and more to the point, the thickness might not be perhaps where you'd want it to be. So we'll have a closer look at that as we go through. But right now, let's get set up, and I'll come back when we're ready to start the process. Okay, so our first step is the alkaline cleaner degreaser, and we're literally just going to drop those in there, and I like to do that for about 2 minutes, something like that. Depends on how dirty the part is, but it is just a standard cleaner degreaser. You do need to be careful with some of these solutions. They are quite harmful. I've got the workshop doors open. There will be fumes coming off of these because of obviously the heaters are in there, and certainly in the winter you can see steam rising off these. These are sat at about 30 degrees, 32 degrees. These heaters are self-regulating at about 30 degrees, somewhere around there. We also have a bucket of just cold plain water, and the idea is that as we come out of each of these tanks, we go into the water first, so we're not cross-contaminating between these tanks. Some people like to have multiple tanks of water, so that actually if you come out of here into here, and then into there, back into here, you could in theory be dragging out some of the acid pickle into here before you go into here. Personally, I've never had a problem with it. I just go with the one bucket of water and I change it after each process. So that's now been in there a couple of minutes. Well, it's not a couple of minutes, but it'll be fine for the purposes of what we're doing today. So give that a bit of a wiggle around. We'll come out of there. And we're going to go straight into our water, just to get rid of any of the degrease that might still be on there. And then we're going into our acid pickle. So make sure all of our bolts are covered. There's one there that's not quite covered. Just need to possibly rearrange that one a little bit if we can. There we go, that's better. So hopefully what you can see going on there is quite a bit of fizzing, and we want to be leaving those in there for something like 2 minutes. And you can smell that. I can smell that coming off there. Usually I'd be wearing a mask, but I'm just being careful not to get too close to that process at the moment. So while that's doing that, let's just have a talk about the current settings for the next process. There are calculators online whereby you can work out the surface area of the parts that you are plating, and you can then set your current accordingly. So the idea is that you have to work out the number of square inches that your parts cover, and there are calculations to work out length, diameters, radiuses of bolts, all that sort of thing, so you can get it pretty accurate. When I first started, I used the calculator all of the time. Once you've run through a few of these processes, you sort of get a feel for where it needs to be set. With the amount of bolts we've got in there, I think we're going to be wanting to be at about 2.5 amps, a constant current of 2.5 amps, somewhere around there. There are cheaper ways of being able to regulate the current than buying one of these regulators. You can do it with, so you could literally do it with a car battery and a massive rheostat or variable resistor. If you can get a second-hand one of those, for instance, you could use that. It's a much cheaper way of doing it. You could just do it with that and then put an ammeter in series with the circuit. So you put an ammeter in the red positive line here, and then you would be able to see how much current you're drawing, and you could set it like that. Because I've been doing this a few months now, I've been through those various options, and to be honest, I got to the stage where I just it was just easier to get one of these. They're not that expensive. I think £60 off Amazon, something like that. Yeah, it does the job. It just makes the job much more enjoyable, to be perfectly honest. Let's be fair, that's what this is about. It's a hobby. It needs to be enjoyable. If it's not, why are we doing it? Right, I reckon they've probably had about 2 minutes while I've been rambling on. So if we now pull those out of the acid pickle, we're going to go back into our water. Give that a good old clean. And these have gone quite dull now. I polished these up on the buffing wheel, but actually the acid pickle does really sort of etch the surface, I suppose that's the word for it, etches the surface ready to accept the coating off the zinc. Right, so we're going to go into here now, and what we want to do is make sure that before we start connecting a circuit up and blowing ourselves up, we want to make sure that our 4 zinc plates aren't touching the parts we're trying to plate, and we also need to make sure that these wires on the zinc plates aren't in the electrolyte, because if they are, that's just a short circuit and nothing's going to plate, and in fact this is going to start complaining at that point as well. So I'm happy with that. Our zinc plates are in place, nothing's touching. Ideally it's better if you have the parts towards the surface of the electrolytes. Apparently that helps with the plating. But let's get this going and then we can talk a bit more about it. So our red lead is connected to this cable or wire, and this wire is connected in turn to each of those plates. Okay, and then what we're going to do is we're going to take our negative lead and we're going to connect that to our bar. So our circuit is now complete, in as much as we're going from our power supply through the cable, through the zinc plate, and then through the electrolyte onto the parts to be coated, and then up the wires, and then the return is through the black wire. So this process basically takes the zinc from the plates, or some zinc from the plates, and transfers it through the electrolyte onto our parts. So I'm now going to turn this on and set an output, and I've now got a constant current of 2.5 amps running through there. Now, several things are going to happen at this point. You might see nothing happening whatsoever, and if that's the case, it might be that the current flow through the electrolyte is not enough, which means it's going to take a long time for the plates to parts to plate. Or you could see a huge amount of fizzing and activity and bubbling, in which case your parts are going to probably end up feeling rough and they're going to look dull, and you're just going to have to start from scratch. The great thing about this process is you can literally, if it doesn't work, if they come out dull or they're rough or it just hasn't worked, you can literally just start from right at the back at the beginning. You can put the parts back in the blast cabinet, blast it all off, clean them all up again, start from scratch. There are quite a few reasons why this process can go wrong, or more to the point, why it doesn't work as well as can be expected, or that you would like, I should say. Your zinc plates could have worn out. The electrolyte suffers from what they call pull out. So when you mix up this electrolyte, you put in something called a brightener, and the brightener does exactly what it says on the tin. It makes the parts bright, or hopefully makes them bright during the plating process. Pull out basically means as you take these parts in and out, some of that brightener disappears, because it's still on the parts. So you might need to put some more brightener in. Sometimes the solution itself can just get murky and bits and pieces floating around in it, and that doesn't help and makes plating difficult. Yeah, these kits come with, well, this particular kit comes with quite a comprehensive instruction sheets and safety data, and it's definitely worth reading that and taking it all in, and just experiment with this stuff and give it a go. I wouldn't immediately start on parts that you want for a project. Maybe just get some small offcuts of mild steel or whatever it happens, old bolts that you've got lying around from another project, an old project or whatever, and give it a go. I suppose this entire setup with the so what I got in the kit were all the chemicals you needed let's start off with that. So in the kit you get the chemicals you need for the degreaser, the acid pickle, the electrolyte, the surfactant, and you can choose a passivate that you want, and then you can buy more passivates afterwards. That's pretty much what we get in the kit. You can then add in your power supply. I did put a basic power supply in the original kit when I ordered it, but I say I didn't get on with it particularly well because I couldn't alter the current sufficiently, so I got rid of that and I bought this one separately, so that's probably another £60 on top. I think the original kit cost me about £70, and then I've added other passivates as well, so probably I suppose the whole setup £150, something like that. You know, I don't know how much it would cost you to go and get a bunch of stuff plated at a professional platers, but if you can, the nice thing about this is you can reuse all of this stuff. It's not just a one shot deal. As long as you keep these things clean, you keep the lids on them when you're not using them, you can reuse these over and over and over. What you do need to do is when you have finished, you should be taking the zinc plates out of here, otherwise the electrolyte gets loaded with zinc and it just doesn't work as well, so you do need to remember to take those out afterwards. You can buy agitators, or like a fish tank type unit that goes into these tanks, or you can have bigger tanks if you want, so you can have whatever size you want, but ultimately they do say you should agitate the electrolyte as it's doing its thing. I've never had an issue with it, to be honest, but I do occasionally just sort of shake the parts around. Don't know if it helps, if I'm perfectly honest, but so we need to leave that now for about half an hour. They reckon it takes about half an hour to 50 minutes to do its thing and get the right thickness of zinc on there. I can't see a lot happening at the moment, I'll be honest with you, so I may up the current shortly, but I'd rather leave them in longer than end up in a situation where we have to start from scratch because they've all gone all rough and dull, etc. So we'll leave it at 2.5 amps for now, and we'll see how we get on, and we'll come back in a bit, in about 30 minutes or so. Okay, so we're back after quite a bit longer than I was expecting, to be honest, because I think I've put too much in this tank. One of the problems with doing that is if your power supply can't output the constant current required to for the amount of parts that you've got in your tank, then it just takes much longer than you were expecting. So these, I think this has been in for almost pretty much an hour now, and I've ended up turning it right up to, well, the maximum output of this power supply, which is 5.2 amps, but I think we're there now. So I'm going to turn the output of this off, and I'm going to disconnect our circuit, and then we now need to take this out and straight into the water. Give that a decent rinse off. And then into our surfactant. And it suggests that you give this a couple of rinses off. So in other words, you put it in, rinse it, put it in again, rinse it, and then we go into the Passivate. So we'll come out of there, back into the water. It's not looking quite as shiny as I would have liked looking at it, but not bad. But I think the electrolyte in my tank's getting old. So back into the surfactant. I did notice when I looked at the surfactant that sometimes you can use hydrochloric acid instead of this. I guess what it does is it just lightly edges the surface again, ready for the passivate. So I'm not entirely sure what that does, but apparently it's an important step. So I'm going to come out of my water now. The passivates, some have to be left in, sometimes parts have to be left in for 2 minutes, sometimes it's 30-40 seconds, depends on which one you're using, so you need to read the instructions. This one says 30 to 40 seconds, I think, something like that. So we're going to leave that sort of 35 seconds or 30 seconds, somewhere out while I'm talking. So you're not going to notice a lot of difference when it comes out of this particular passivate, because it is literally just a clear coating. It does tend to go slightly bluish, it's got a slightly blue hue to it, which you often see on Japanese motorcycles when these parts have been done like this, so that works out quite well. But again, some of these, once they come out of here and you've rinsed them, some you let air dry, some you can do with a hairdryer, some it suggests putting into an oven to sort of bake it on, I suppose, or make sure it goes hard. So once we've had our 30 seconds or so in the passivate, out of there, into our water, out of the water, and basically we're done. So that is the process. And now what we're going to do is we're going to let that air dry over on a piece of kitchen roll for a while till it's dried off, and then they're ready to use. So once our process is all finished, we're going to let those dry, and what we need to do now is just close up all of this stuff. So turn the heaters off, turn our power supply off, and put the lids back on these as best we can. Also remember to take the zinc plates out of this electrolyte, because otherwise the zinc will just leach into the electrolyte and it will completely lose its effectiveness. So it is important to remember to take those out. But, you know, if you're not using the tank for a day or a few days, I always take them out. Yeah, and that basically is the zinc plating process. I'll show you some of the results that I've had, and if you've got any questions, please leave them in the comments. Okay, so these are some that I did the other day, and that's the sort of results that I'm getting. And you can see there's a sort of blue hue to that, which is typical really of the sort of fasteners that you get. Well, a typical sort of zinc plated fastener with a clear passivate on. So if we compare that with, come over here, so this lot, so these are all professionally plated, and if I'll take a look at that, you can see that's has a blue hue to it as well. So that's the sort of thing that you get if you take it to a plater's, and so I'm pretty pleased with those. So they can go back on once I've finished the rest of the wheel. So that's where I'm going to end today's video. Thanks very much for watching. If you've enjoyed the video, please give it a like down below and subscribe to the channel, and I'll see you in the next one.